Okay, I'm going to discuss about the 19th lesson. So today I'm going to start the 19th lesson. It is current electricity, grade 10, 19th lesson. Current electricity. There you have to learn 7 subtopics under this main topic. First one is static electricity and current electricity. Static electricity and current electricity. Second one, electricity flowing through conductors. Third one, potential difference and the electromotive force. Fourth one, relationship between the current flowing through a conductor and potential difference across the conductor. Fifth one, factors affecting the resistance of a conductor. Six, resistors. Resistors. Seventh one, combination of resistors. Okay, first one, static electricity and current electricity. Next one, electricity flowing through conductors. Okay, let's go to the lesson, page number 140, and then just start. 140, no? Okay, here we came to the lesson. Current electricity. Static electricity and current electricity. Electricity is a very important form of energy to us. So a form of energy. Highlight form of energy. In the modern world, many instruments are manufactured in a way that they could be operated using electricity. Is that true? Yeah, in the modern world, we know each and every equipment we use, we have to use them with the power of electricity, like the TV, mobile phone, we have to charge, rice cooker, electric kettles, and everyday day-to-day things we have to just the bulbs, switch on the bulbs, fans, air conditioners. So all the things we have to use. All the equipments, most of the equipments should be operated using electricity. Household equipment such as electric bulb, electric irons, electric fans are some of the examples. Electricity basically has two forms. What are them? Static electricity and current electricity. That is the first subtopic of ours. You have learned in grade 7 and 9 that static electricity consists of charges that are deposited on the surfaces of the insulators and that they do not flow. Now let us investigate the behavior of static electricity. Rub a drinking straw well with the cotton material. Rub a drinking straw well with the cotton material and bring it close to tiny bits of paper as shown in the figure. 19.2. 19.2, it has shown that they have taken this comb. Instead of the comb, we are going to take this drinking straw near to these bits of paper. You will observe that the bits of paper get attracted to the straw rubbed with the piece of cotton cloth. Also bring another straw that was not rubbed with the cotton cloth close to tiny pieces of paper. We will notice that the bits of paper would not be attracted to straw. මුලින්ම මේ drinking straw එකක් cotton cloth එකකින් rub කරලා drinking straw එක මේ වගේ චූටි pieces of paper or like tiny bits of paper වගේ ළඟට ගෙනාවොත් එහෙම what happen? It get attracted. ඒ වගේම මෙහෙම rub කරපු නැති drinking straw එකක් ගෙනාවොත් ඒකට attract වෙන්නේ නැහැ. Rub a plastic rod, pen or a comb near a drinking straw. Here with the cotton material and plastic rod, pen or comb against your hair and bring it near tiny bits of paper or tiny pieces of rigiform. You will observe that these tiny pieces being attracted to the items rubbed with hair. Figure 19 shows little bits of rigiform being attracted to a rubbed comb. Try the above with the plastic rod that was not rubbed with hair. You will observe that the rigiform pieces do not get attracted to it. So with rubbing, it gets some kind of charge, okay? When some objects are rubbed, they acquire a force of attract little pieces of paper, dust, and other light materials. Such objects acquire this attractive power through the static electric charges generated by rubbing. You have observed that objects such as a drinking straw or a comb attract tiny bits of paper only after rubbing them, and if the objects are not rubbed, they cannot attract bits of paper. Read it again and check whether you understood it. Okay. How are static electric charges that give certain objects an attractive power generated? All materials are composed of atoms. Now we are going to check how these absorbance, attraction, that force of attraction, how these objects got it by rubbing. රබ් කරලා කොහොමද මේකට මෙහෙම මේ එනර්ජි එකක් ආවේ මේ තව මොන හරි පොඩි pieces of paper attract කරන්න පුළුවන් තරම් එනර්ජි එකක් ආවේ කොහෙන්ද නිකන් රබ් කරපු නැති එකේම එනර්ජි එකක් නැහැනේ. ඒතර කොහොමද මේක උනේ කියලා බලන්න තමයි දැන් යන්නේ. ඒතර how are static electric charges that give certain objects an attractive power generated? All materials are composed of atoms. You already know. හැම material එකම හැදලා තියෙන්නේ atoms වලින්. All materials are composed of atoms. Atoms consist of tiny particles known as what? Electron, proton, neutron. You already know it. So protons are positively charged and electrons are negatively charged. Yeah, you know this one too, okay? Neutrons do not have a charge. They are neutral. Neutron are neutral. So protons and neutrons are found in the center of an atom known as nucleus. See, the protons are showed by that yellow color one because it contains that positive charge mark, and neutron it does not have any kind of mark, so they are negative ones. Sorry, they are neutral ones. Protons positive and neutron neutral. So they are in the core of the center of the atom. The center, the core of the atom. Center of the atom, nucleus. They are in the nucleus. Proton, neutron are in the nucleus. Which is, you don't need to highlight that center of the atom because you already know protons and neutrons are in the nucleus. But electrons, where? They are found in rotating around the nucleus. So only electrons can be removed from an atom easily. Only electrons can be removed from atom easily. If electrons are removed from an atom, okay, if electrons are removed from an atom, on the surface of an object. Object එක surface එකකින් after rubbing it with a piece of cloth, positive charges are generated on the surface of the object. That is, the surface is positively charged. That means if there are same number of electrons and protons in an object surface, if you remove electron charges by rubbing, it has an electron deficiency. That means it just have more positive ions. Okay, so more positive ions, and it became positively charged. If the object receives the while rubbing, if electrons are lost from one object surface, so they have to go to the other object surface. So if the number of electrons in a surface, in a neutral surface, non-charged surface increases. يعني අපි දැන් මොකක් හරි රබ් කරාද එතන ඉලෙක්ට්‍රෝන ටිකක් ඩෙෆිෂන්ස් වුණා නම් ඉලෙක්ට්‍රෝන ටිකක් වෙන කාට හරි රබ් කරන දෙන්නගේ එක්කෙනෙක් ගාවට ගියා නම් ඒ දැන් ඉලෙක්ට්‍රෝන අඩු වෙච්ච එකට නෑ මගේ අපි හිතමු left hand and right hand කියලා. left hand and right hand එක රබ් කරද්දී left hand එකේ ඉඳන් right hand එකට electrons ගියා නම් left hand එකට electron deficiency එකක් එනවනේ. ඒතකොට left hand එකේ electron deficiency එක නිසා එයා positively charge වෙනවා. ඒතකොට right hand එකට ගියානේ electrons ටික. ඒතකොට right hand එකට ගියපු නිසා right hand එකේ already තිබ්බ electrons ගන්න වැඩි වුණා. ඒ නිසා එයා negatively charge වෙනවා. හරිද? core එකේ තියෙන protons and neutrons, they can't move because they are in the nucleus, in the middle part of the atom. We highlighted this. Only electrons can be removed from an atom easily and can be added to an atom easily, vice versa. So that is here. So that is the surface is positively charged. If the object receives electrons from the piece of cloth after being rubbed with the cloth, then the surface of the object acquires a negative charge. That is, the surface gets negatively charged. So charges that are found stationary on an object in this manner are known as electrostatic charges. When such accumulated electrostatic charges begin to move, they give rise to an electric current. In order to find out how to generate an electric current from electrostatic charges, let us engage activity 19.1. Okay, hence this is a little bit long lesson. You have to study more in here. For now, I'm going to stop here. Okay, I'm going to stop here, Lamai. And we are going to discuss from the next part again, because we are just in the first part of the lesson still. So I need to do this one in very simple way before we come to these conductors. I'm going to stop it here and we'll discuss this later, other part. Okay, thank you.